We are standing in front of the 1510 Webster Street development in Oakland, California. And 1510 Webster Street is a 19-story multifamily residential building. We're at the 1510 Webster Street development in Oakland, California. It's a 19-story multifamily residential building, and it's incredibly important and unique for our industry because it will be the tallest mass timber building west of the Mississippi when it's completed.
We typically build these buildings with steel and concrete, and now this is a perfect example of a building that is now built with another construction type, wood, that can handle fire, can handle seismic, and provide a much faster construction type at a cost savings than traditional construction materials.
DCI teamed up with oWOW Development, which is a vertically integrated company which includes the development, architectural, and construction team. Actually started the design before the building code actually even allowed for mass timber of this scale. That was the foresight that they had to realize the value that mass timber was going to be able to provide for a project such as this. So it was a very collaborative process that we worked with in oWOW in order to be able to figure out the detailing, the construction sequencing, and especially the testing of the material in order to really take advantage of what MPP can do for this type of project.
So 1510 Webster is the first mass plywood panel point supported building in the world.
Mass plywood panels are essentially really thick plywood sections, which is essentially really thick plywood. It just keeps getting built up to 4, 5, 12 inches thick, depending on the strength and the characteristics that we need from it. Unlike CLT, it utilizes the entire piece of lumber when it's constructed, so it's extremely sustainable material to build with. Also extremely lightweight, so it gives us a lot of structural advantages in terms of limiting the mass of the building, which limits the seismic forces that we need to design for it.
And so basically the panels are spanning from column to column, and that's how we span two directions. So we span one direction the strong axis, one direction the weak axis, and this allows us to go to a thinner wood panel, saving wood fiber on the building. It's a new cross-laminated timber product, and it's based on an LVL specification. The current design values in the MPP design guide show that we needed a 6-inch thick panel to span this distance to carry this load. And so we as DCI and the oWOW team felt that those values were undervalued. DCI developed a finite element model. We developed an analysis of the two-way bending of the panels, and we did a test setup at Wood Research and Development. The testing that DCI and oWOW did showed we only needed a 5-inch panel to carry this load and span this distance, and that saved us 16% on wood fiber volume on the entire surface of every floor of this 17-story mass timber building.
One of the biggest challenges that we have in mass timber construction within a high seismic zone is going to be how to interface the mass timber panels with the concrete core. DCI has developed the corbel connection here to facilitate a gravity and seismic connection all in one. This connection reduced the amount of embed plates by about 60%. The corbel connection is going to allow for easy installation of the panels by notching the panel around this and just allowing it to sit directly on top and facilitate the tolerances that we need. From our panel-to-panel connections, we utilized the Simpson LDSS strap. This is going to be very advantageous in reducing our overall diaphragm deflections. DCI collaborated with the other design consultants to ensure that all the penetrations on the project were in the right location while providing adequate stiffness for the panels. Getting these penetrations set prior to installation of the panel can dramatically save time of installation. DCI teamed up with Rotherboss for the pillar connection here so that the different levels are going to have different thickness to be able to transfer the force without bearing on the panel itself. This connection is also really unique in how easy it is to install. It's only going to take a couple of minutes per column.
Construction types have been adopted in the building code by many jurisdictions. That code language is there, it provides prescriptive requirements, but actually constructing the building and finding out all the details and nuances that happen with designing and engineering and constructing a building of this type, you need a team that can take you through that process and get it to completion. So City of Oakland was very receptive in helping us develop this first Type 4A in all of North America. 1510 Webster is a groundbreaking project for the wood industry.
As we know, California has a huge shortage of housing, and one of the challenges of that is simply the cost of construction and the amount of challenges that we have to overcome in order to get a residential building like this built. Mass timber construction is extremely important for Oakland, the Bay Area, and really throughout the country because it provides another option for us to build mid-rise and high-rise residential construction in a cost-effective and efficient way. The hopes is that this will allow us to help alleviate some of the housing challenges that we face throughout California and throughout the West Coast and help us deliver more projects, more housing, and more affordable housing throughout the communities that we work in.